Hello, Algebra 2 kids. Today I'm going to go over page 8 of your Regents Review, taking a look at number 22. You do not know how to do this one yet, but I did give you a little hint a couple pages ago. So we've got a mayor. Come on. There we go. Running for an election. 264 out of 550 voters said they would vote for this guy. Okay, so the first thing I'm going to do is I'm going to calculate what proportion would he earn of this vote if this was the deal. So I would do 264 divided by 550. I would type that into my calculator. It comes out 0.48. All right, so the deal is here, about 48% of the people are planning on voting for this guy. We're looking for which statement is least appropriate. So this is something you have to learn, excuse me, in Algebra 2. After calculating a proportion, you have to realize that this is not what's going to happen. Okay, it could happen, but it is not exactly going to happen. So what we have to calculate is something called margin of error. We talked about that a couple pages ago. I don't even know where it was now. There is a formula to calculate margin of error. It's 2 standard deviations, okay? So margin of error is 2 standard deviations. Do you remember that formula I told you about? Okay, you have to memorize this one. You take the proportion, under a square root by the way, times 1 minus the same proportion over the number of people that were asked. Now, because we're calculating a margin of error here, or figuring out how far off could this be, we have to multiply it by 2 standard deviations. So for this question, the proportion was, well, hold on, big square root first. Proportion was 48%, 1 minus 48% over, how many people? 550 people were asked. Okay, pick up your calculator. Oh, the lights again. Gotta love it. Let's come over onto this side. Menu, calculator. Here we go. Let's do it by 2 right off the bat. Square root and a fraction while we're at it. 0.48 times 1 minus 0.48 over how many people? 550. So the margin of error is about 4%, right? Boom, boom, move it 2 places. So we're saying that this could be off by 4%, 0.04. All right, so this gives you an idea of how many people are actually going to vote for this mayor. So if you have 48% and you're 4 off on the low side, you'd get 44%. If you had 48% and you were off high this way, 48, 49, 50, 51 is 52%. So we would expect the mayor to get between 44 to 52% of the vote. So let's take a look. Which one is least appropriate? There's a 48% chance that Mayor Ortega will win the election. They want you to pick this one. This is a distractor, okay? Yes, it came out to 48, but remember, we were off by 0.04. So it could be anywhere in this range. This is not, this is not an appropriate, this is not a distractor. Holy cow, that's the answer. That's a horrible thing to do. 48, they want 48, nope, it's off. Here's the other point estimate. Don't even worry about that. This is the straight up probability. This is accurate, okay? The point estimate of voters is 48. We calculated that. It's most likely that between 44 and 52% of voters will vote. That is exactly what we calculated, 44 to 52. That is true. And last but not least, due to the margin of error, an inference cannot be made regarding whether he will win or his opponent will win. Why? You need over half, right? And the problem is this guy could get over half and win, or he might fall short. So we cannot determine if he's going to win or not. So the worst answer is going to be number 1. There's a 48% chance that he will win because of this margin of error, okay? Question 23. This one you should know how to do. It's disgusting, and we've done this one several times. This exponent right here belongs to everybody. So that's what I'm going to do. I'm going to take a negative 54 and give the exponent. I'm going to give an x to the 9th. I'm going to give that exponent. And I'm going to take a y to the 4th, and I'm going to give that exponent. All right? So, like I said, totally disgusting. I would type this in your calculator. You have two options. It's either going to come out non-real calculation because of that, or it's going to come out with a decimal, and it will be these. Okay, so if I go and I type it in, negative 54 to the 2/3, right? It comes out, oops, my calculator will do this. Yours won't. Yours will do that. Okay, it came out a real number. So I know this and this are not good answers. So I have to figure out which one of these is the correct answer. This is all the same, right? This and this are the same. So I'm not even going to worry about that top. I'm only going to look right here. Okay, well, let's just show you. Multiply these two. 9 times 2 is 18 divided by 3 is where that x to the 6th comes from. Okay, so we're going to do the same thing here. We're going to multiply these two together. So 4 times 2 is 8 divided by 3. Ooh, 8 divided by 3. That's not very pretty. So what I have to do is I have to figure out how do you reduce this in the bottom to come out to either y cube root of y or y squared cube root of y squared. And there's a couple different ways you can do it. One way that kids have done it recently is they will change this to a mixed number. All right, so 3 goes into 8 twice. 2 times 3 is 6, which leaves me with 2/3 left over. So what this breaks down into is a y squared and a y to the 2/3. And then we have to remember that anytime you have a fractional exponent, this is really huge for Algebra 2, guys. The bottom of the exponent becomes the root, and the top guy, who is in the exponent spot, remains in the exponent spot. So the only answer that comes up with this is number 4. You can also get around this question, guys, by doing x in your calculator, x funky equal sign 2 or something like that, y funky equal sign 3. Type this whole thing in. You're going to get a decimal. Type the answers in, see which one gives you the same decimal. Okay, this one I have not taught you yet. Well, little pieces I've taught you back in Algebra 1. This family is going to set up an account for their daughter to pay for her college. The day their daughter was born, they deposited $1,000. Every year, oh, by the way, it's going to pay 1.8% compounded annually. That is the 9th grade formula, the Algebra 1 formula I taught you guys about. Beginning with her first birthday, they deposited an additional $750 every birthday. Okay, so which expression is going to represent that? So all I'm going to do is I'm just going to do this out just quick. So on her first birthday, right, this is going to grow by 1.8%. So we're going to grow it by 1.8. The easiest way to do that is you are going to take the $1,000 and you're going to multiply it by 1 for 100%. We're going to keep that $1,000 and we're going to grow it. And then I'm going to put the percentage. 1.8% is 0.18. All right. So on her first birthday, after earning interest, this girl is going to have $1,018. But here's the deal. What are the parents going to do on that first birthday? They're going to give her $750 more. Okay. So that becomes $1,768. So then on her second birthday, this is the amount in her account. This is going to earn that 1.8% interest. So I'm going to take this. Oops, I have to add my $750 first. Oopsies. Oh, good Lord. $750. That's what happens when you watch your phone. Times 1, because she's keeping that $1,768, and on top of it, we're going to get 0.018. That's 1.8%. So on her second birthday, in that account will be $1,799.82. But what else are they going to do on that second birthday? They're going to walk to the bank, or maybe drive, and they're going to add in $750 for her birthday, plus $750. She's going to end up with $2,549.82. Let's do one more birthday. On her third birthday, this is how much money is in her account. She's going to get 1.8% interest on that. So times 1 for 100%. 0.18 is your interest. $25.95.72. But what are they going to do on that third birthday? They're going to walk on down to the bank. They're going to put $750 more in there for a grand total of $3,345.72. That's how much money is in her account at the end of the third year. So why did I do it? Did I have to do this? No. But I want you to see that we're going to start with this amount. We're going to grow it by 1.8%. Abs, you got to turn, Lee, turn it off, babe. Okay, we're going to start with this amount. We're going to grow it by a percentage and then add that amount. Then we're going to take this amount. We're going to grow it by 1.8 and then we're going to add 750. Then you take this amount and you grow it by 1.8 and then add 750. That's a recursive formula, guys. Here they're saying you're going to start with $1,000. We took the amount that was in the account the year before times 1.018 and then I added 750, right? So to find this amount, I took the $1,000, boom. I multiplied by 1.018. That gave me this. And then I added 750. Boom. To find this amount, I took the year before it. I multiplied it by 1.8%. And then I added 750. This is telling me to do that. I miss you guys. I hope you're all doing well and working hard every now and then. As always, if you have questions, well, you can't come see me. I take that back. Don't come see me. Stay at home. Stay distanced. But send me a message through whatever method, okay? Bye, guys. I'll talk to you later.